Okay, well, this is my first try at doing screen capture with Zoom to make a lecture. And in this case, the lecture is going to be on the topic of the use of R for statistical analysis. And so normally what we would do is I'd do a lecture on this with everything in PowerPoint, but in this case, we're going to try to do it using our studio in real time. And if you look on Canvas in the files section in the folder for week 5, you'll see that there is a file called chickdata.r. And that's the file I'm going to be working off of here. And this will show you what things should look like. And I'm just going to scroll up here because there's some stuff that I did beforehand that of interest to you. So let's start with this. Okay, so there's our first introduction to R. First thing we're going to do is we're going to initialize any variables. So I'm going to go down to the console window and just say x equals 1. If we had variables defined from some analysis, the following command that I talked about in lecture removes them. And you can see now that the environment is empty. So the first thing we need to do is to make sure that we have the packages we need. So I'm going to install the package psych. And what this tells me is that it's been successfully unpacked and it's the correct package and the correct version and all that sort of good stuff. So we're going to now tell R that we want to use that package by saying library psych. So the first thing we're going to do is we're going to bring the data in. We're going to manipulate the columns and rows. Now, the first thing you need to do is copy the files over to your own directory. And then we're going to set our working directory. Basically, the working directory is just the directory that R will look at by default. So if we say we want to open up a file called hello.r, the first place it's going to look is in this working directory. Okay, so there are a number of ways we can do this. For instance, the command we're going to use is called setwd, working directory. And here's a little clever thing you can do, which is choose.dir, another function. So choose.dir, the function is gonna look for, it's gonna open up a dialog window, and hopefully you'll be able to see this. And then once we've selected a dialog, so I'm going to browse to, and because it's the first time I've done this, I don't know if you can see it, but basically I'm going to browse to the directory in which I keep the files for this week's lectures and labs. So boom. The result of choose directory is a character string, and that gets passed to setwd. So, and setwd actually does the telling R where I'm going to use it. Another way to do it is you could just use setwd with a string, a character string, and that's where I'm keeping my data. But R interprets the slashes that we use in Windows to indicate where directories are as escapes. What does that mean? It means basically that if you do /C, for instance, it thinks that that's a control C. So we don't want to do that. So we got to double up on the slashes. Okay. Oh, now look, I typed in get WD to see what the working directory it is, and I hit return. And that was a mistake because I put in get WD, and what it replied was, it told me, oh, get WD, I know what that is. That's a function. It's an internal function, and here's some details about it. What I meant to do was to actually call the function by putting in the parentheses. So there you go. Okay, so now we're set up. Okay, the first thing we're going to do is we're going to open or import the data set, a standard data set that's inside the psych R package, and that's called chickweight. And I just did that, and as a consequence, this has appeared up in the environment. Our data, we have the variable chickweight, 578 observations of 4 variables. We can get more information either by clicking this little triangle, having things come down, and telling us, okay, so what variables are here: weight, time, chick, and diet, the diet that those particular chicks were on. Okay, and this gives more details about the values, the definitions for all these variables. The other thing you can do is you could double click, and that's going to open up the data set as a sort of a table. Whoops. Ooh. My screen just got kind of wacky. I hope that didn't happen on the video as well. It may be as a consequence of having the video. And it makes me realize that chick is an identifier for each of the chicks. And so that we could keep track of them over time. So we have their weight and time, and we want to track their weight over time. So we need to have a code for the chick, and then we have a code for what diet that particular chick was on. I'm going to go back to the chickdata.r, and I'm going to say, okay, show me the just the first couple of observations. There you go. And give me some information about this data. We've already seen it in the GUI, but very often you want to do this sort of thing programmatically. That is, you want to have a function, say, that tells you, that requires the number of rows in order to do the processing. So we can use the nrow command. The ncolumn command. 4 columns, 578 rows, as we've seen before. The names of the columns. Okay. And then we can look at what class is that chickweight diet variable. It says that's a factor. Now we can ask, well, what are the levels? Since it's a factor, what are the levels of that factor? And there are 4. Okay, so those are 4 different kinds of diets that the chicks were fed. And then finally, what's the class of the or data type of the chickweight $time variable? And that's numeric. Okay, so let's call up a summarization of the data set. So simple thing, it's just going to tell us, you know, a series of statistics about each of the variables in chick weight. So weight, time, chick, and diet. Weight and time are both what are they? The floating points, the numerics, yes. And so since that means that, you know, that tells R that we're going to give, these are sort of continuous things, continuous variables, then so we have our weight and it's and time. Though for those two variables, we're going to show, you know, statistics about their distribution. So mean, median, first and third quartile, minimum and maximum values. Chick is an ordinal variable, or ordinal factor. So that means that it's, you know, it's basically it's naming something. And so it just shows us how many observations there are of some values of chick. So there are 12 values of chick 13, 12 values for chick 9, et cetera, et cetera, et cetera. And then finally for diet, we have 4 levels and we have the number of observations of each of those 4 levels. And it looks like, you know, the first diet was sort of the control diet. And so they had more chicks in that. And it looks like if you look at diet 4, that there are 2 observations missing. And so maybe something happened to those chicks. Maybe 4 wasn't the best diet. Kind of a sad thought, but nevertheless, we continue. Component 3, we're going to talk about data subset. So how can we, for instance, look at just the chicks that have, who are on diet 1? Well, here's a command, and we're going to take the chick weight. You're on the right side of this assignment. We're going to take those chicks where the chick diet was equal to 1, okay, and get all of their variables. So these are observations here on this side of the bracket, or this side of the comma in the bracket, and on this side would be all the variables. And as I've said before, because there's nothing on this side, then R interprets that as meaning we want all of the variables. So now we have a new variable, chick weight, diet 1. If we look up in our data in the upper right-hand corner, we have a new variable with 220 observations, as we'd expect. And I'm going to use the up arrow to go back and to my summary line, and now we'll just get the summary for chick weight 1. And that didn't work. Oh, sorry, should have been chick weight diet 1. There we go. And so when we look at this, we'll just very quickly compare this. The mean of the mean weight for these chickens with diet 1 was 102. If we go back up to the overall mean weight for chickens for all 4 diets, it was 121. So these chickens are a little smaller that had diet 1. And the time is the same as you kind of expect. They're just time there is just a, you know, a variable that is used to keep the samples, let us know what samples are being used. And in this new data set, chick weight diet 1, if we look over at the diet variable, then there are 220 observations of chickweight 1. So that's what we'd expect. So I'm going to define now all of the 4 chickweight diet variables. And if you look up in the environment, this has been done. Okay, so we did we've got now 5 data sets, the original, 4 data sets, 1 for each one of the diets. And in the chickdata.r file, there's showing you another way to do subsetting. So this is defining a new variable using an explicit subset command. You can do it either way. Now, I'm going to define a new function here on the command line. And that is a function that's going to do 3 things at once, okay? One of the neat things about R and many other sort of modern languages is that the way to define a function is by you declare a function the same way you would, you could declare a function and just assign that to a variable, and that variable becomes the function. So this line here is saying, define a new function, labstats, that operates on the value x and returns a vector, which we're creating with C, concatenate, the standard deviation of x, the standard deviation of x squared, variance, and then the standard deviation of x divided by the square root of the length of x. And you should remember that length is just tells you the number of elements in a vector. So I'm going to make this definition, labstats, and it shows up in the environment. So now I can use one command to calculate those 3 statistics for both length and mass, or for any other variable in there. So that's chicken weight 1. I'm sorry, chicken weight diet 1, chicken weight diet 2, chicken weight diet 3, and chicken weight diet 4. Okay. Very easy to define these functions in R. Now I'm going to create some scatter plots. And as discussed in the lecture, I'm going to use this par command. And I'm going to specify this keyword to par, mf row. And I'm going to give it a vector that consists of the elements 2 and 2. What that's going to do is it's going to set up a plotting window in which we have 2 columns and 2 rows for graphs. If I go over here at the lower right to the lower right panel and hit plots, well, nothing, you can't see anything, but that's been set up. Now I'm going to plot the relationship between weight and time for each one of the diets. So for each one of those subsets, we're going to do plot. And there you go. Very simple. So, and because R does some automatic labeling for us, we can tell looking over at the plots that The one in the upper left-hand corner is chicken weight diet 1, chicken weight diet 2 is to the right. Bottom left is chicken weight diet 3, and bottom right is chicken weight diet 4. And on the x-axis is time, and on the y-axis is weight. And unfortunately, the axes here are a little different in each case, because R has done a has sort of auto scaled to make them look nice, but I think you can get the general idea here that, for instance, chicken diet 3 seems to have the chickens with the highest heights, the highest weights as a function of time. The other is, there seems to be more spread in chicken diet 1 and 2 and less in chicken diet 4. Not sure what that's about. Not familiar with the chicken weight diet, chicken weight data set. So now we can create a box plot for each treatment. Now, we could put in a box plot for each one of chicken weight diet 1, chicken weight diet 2, chicken weight diet 3, but instead, we're going to use another incredibly powerful feature of R, which is we're going to do a box plot, but we're going to tell it something about a relationship that we want to test for. So first of all, we're going to reset the windows using that par command again. Okay. Now let's look very carefully at what we're putting here. We're saying, let's do a box plot. Oop. I get Control X instead of Control C. And in that box plot, rather than saying we just want to look at, say, chicken weight variable weight, which would just give us a box plot for all the weights in the chicken weight data set, we've got a little statistical relationship here that's being set up using this tilde symbol. So this has become it's become a common way of saying, giving a sort of a statistical, I guess, hypothesis, which is, or statistical relationship. It's saying, give me a box plot that shows me the weight of these chickens, chick weight, $ weight, as a function of chicken weight diet, chicken weight $ diet. And then we're just putting in some nice labels, and we're going to get a box plot. Hokey smokes, there you go. So the dependent variable here is weight as a function of that tilde command is sort of as a function of chicken diet. And so now we can see we have the mean weights of the chickens as a function of diet, and we know something about their variability from the 25th and 75th percentile of their weights. And then we have ranges, and in this case, for diets 1 and 2, we have some outlier values that are being identified as being greater than, in that last 1.5% of the distribution. So that's great. Now this we can either, export as an image, as a PDF, we can copy it to the clipboard, or, you can just use the snipping tool if you want to grab a copy of that and put it, say, in a PowerPoint or a Word document. In the next step, we're going to do a time series of box plots. So we don't really need to reset the frame there because it's already a single plot. So now we're going to do box plots of weight as a function of the time when the measurement was made. Okay. Oh, I missed one command in that last section, and that was just the title command, adding a title, but we've got a title here for this particular command, so we'll just add that on there at the end. Ta-da, chickweight as a function of time. So two things, obviously they're growing up to, the period 20 and 21, although the rate of growth seems to be slowing down, and the variability becomes greater as well over time. Okay, so we know something about how each diet affects chicken weight, and we know how much time, obviously, as longer the chicken's alive, it's going to affect chicken weight. So now we're going to do some actual statistical techniques on this. So the first thing we're going to do is a regression. Okay. And we're going to look at weight as a function of time. Now, in the next command, we've simplified our equations somewhat. So first things first, we're setting up a linear model here. We're setting up a variable that LM underscore chickweight that will receive the results from LM, which is a linear model. Okay. And we're going to specify the relationship we're interested in. Weight as a function of time. Note time here is capitalized. And rather than going chick weight, $weight, chick weight, $time, we're just going to tell LM that the data we're working with is chick weight. Okay. And when we tell it that, it knows that it should look in that variable, chick weight, for the columns weight and time. So let's do that. Not very interesting. But LM chickweight has been created up here in the environment. And so we can now look at that variable. Now, commands like summary are sensitive to the kind of variable that's being sent to the command. So if we did a summary of the chickweight variables, as we did before, that told us something about what the variables were what the distribution of those variables were. In this case, it's going to give us a summary of the model.